Welcome to this webinar about managing research software. And this webinar is being organized by the LIBER Research Data Management Working Group. And my name is Elisa. I am the one of the co-chairs for this working group. Just right out of the bat, I want to announce that this meeting is being recorded, and after the webinar, it will also be posted on the LIBER YouTube channel. So if you would prefer not to be recorded, I would suggest that you switch your camera off, and also please try to keep your microphone muted during the webinar so that we have minimal disruption. Feel free at all times to add your questions in the chat. We will have time for a Q&A at the end of the session, and also the chat will be monitored. So if you have a question, feel free to add it to the chat, and we will ask it after the talks. We will have two presentations today. And we thought, since they kind of follow upon each other, we will have a full Q&A at the end of each presentation. And I would also like to remind all of you that at this webinar we stick to the LIBER Code of Conduct, which you can read and consult on the LIBER website. The bottom line is, please be kind and considerate to everyone in the webinar, and you can also find ways to report breaches of the code of conduct on the LIBER website, but you can also use the chat to message me personally if you feel that that it is really required. Before we really get started with the presentations, I would like to tell you a little bit more about the Research Data Management Working Group, or the RDM Working Group. We have two overall goals. The first is to help research libraries to secure a critical role in the scholarly information infrastructure of the 21st century. And second of all, we want to contribute to a situation in which research data are recognized as valuable academic resources that need to be managed, shared, and preserved to foster research and science. We try to work towards those goals, which activities such as the organization of webinars, this is one of them, and we also organize workshops at LIBER events with regularity. We deliver resources that give guidance to librarians, whether they work in RDM or not. One of our most recent publications is a document that sums up DMPs in a nutshell. That document is meant for library colleagues who don't work in RDM. Our working group also has monthly meetings in which we share information and updates with each other, and we also work together preparing activities like this, and also working towards our goals. And we also try to collaborate with other working groups, LIBER working groups, and working groups from other organizations where this is opportune. And we contribute to task forces to bring forward LIBER's goals and to support LIBER member libraries. So that's about our working group. Now, it is my great pleasure to introduce the first speaker today, and he is my working group colleague, Naeem Muhammad. Naeem works as research data manager at KU Leuven in Belgium. He holds a PhD in software engineering, and he has been actively engaged in research data management for a very long time. He is an active member of our RDM working group, and today his presentation focuses on the concept of fairness in research software. As attention to managing research software has grown alongside FAIR data, this session will detail how the FAIR principles apply directly to research software. And I will stop sharing. And I will give the floor to Naeem.
Yeah, thank you very much, Elisa, for the introduction, and Hannah for organizing this wonderful webinar. As Elisa said, like awareness around research software, fairness in research software has grown. So it's about time to really know what exactly is needed in order to make research software fair. So during this talk, I will try to outline some practical ways of making research software fair in line with the fair data principle. Usually fair data principles are applied on all kind of research data, but one important aspect actually is ignored for many reasons. One of them actually is that there is less information available in concrete terms how to apply those principles. So I will try to outline some practical ways of doing that. And I'll also talk about how good code management actually help you to create fairness in research software. Briefly, I'll talk about important component of software sharing, that is software licenses. And if time permits, I would like to use one of the available online assessment tools to see what exactly fair assessment in software looks like. But before I do that, I would like to actually give a bit of background. So research data, which we all know, is usually considered a kind of mm, experimental numerical data. It could be images, videos, it can be interviews, outputs, or in some cases it can be lab specimens. But research, when you talk to researchers, usually they are confused whether they should consider software tools or scripts that they develop to assist their work should be considered as research data or not. Over a period of time, with the help of artifacts like data management plans, for instance, this aspect has been clarified. Now, almost all funders who require a DMP emphasize and clearly put some examples that software or whatever actually script that you develop as part of your research work is considered as research data. And we know that fair data principles, which are quite popular principles when it comes to research data, uh, yeah, so those principles then needs to be applied on software as well, regardless of the magnitude it may have. Now, in the past, the software domain was mainly tackled by the open source community, where open source ambassadors came together to really start this movement that source code should be available. But there was no emphasis at that time on making those open source tools as kind of fair. So in recent past, open science community, fair data communities, and open source communities joined forces to come up with fair principles for software, or more specifically research software. So today's talk will be about that particular fair data principles for research software. Yeah, but first we need to define what actually research software is. There are a lot of definition of software, but we need to be specific what a research software actually could be. So, and a simple example that I found is really can clarify that matter. A computer-based application that converts inputs into outputs to support the user in one or more research tasks. So here it's very important that it's about research tasks. So there are many commercial tools available in different kind of work domains, but any tool that converts inputs into outputs specifically for research tasks. So what it could be in general research setting, it could be a kind of post or a pre-processing scripts. It could be simulation scripts that researchers actually develop to do some certain kind of research, or it could be an analysis script to do certain kind of analysis on the data gathered during a kind of research work. So it's very important that actually, yeah, this context around software is really within the research community. Some other familiar elements that researchers quite often come across, yeah, are listed here. It can be kind of a research-based workflow. It can be a small script developed in maybe Python or MATLAB, or a sophisticated tool developed in Java, for instance, or on C++, or it can be a kind of simple library, yeah, or any executable output from the research work. But all this is considered as research software. Hence, there is a need that fair data principles are applied on whatever actually output is generated by using these workflows or tools within a research setting. Yeah, we all know that yeah, open science movement aims to make scientific research transparent, accessible, and collaborative. But how to do that? That is the big actually question. That question actually is answered by the fair data principle, which provide the foundation for achieving these goals. Fair, which essentially means findable, accessible, interoperable, and reusable data. How does actually it helps to achieve those goals set by open science? Findability, for instance, enables discovery of the scientific output. Accessibility, on the other hand, promotes equitable access to the scientific knowledge. Interoperability can facilitate data integration across disciplines and platforms. Reusability is also important, which encourages the validation of published output or its replication, for instance, or using these reusable outputs to do further innovation. So FAIR principle really a kind of cornerstone of open science movement. Therefore, it needs to be applied on all kind of data that I described earlier, including software. So in a kind of a brief or abstract way, how these FAIR principles are translated into more concrete steps. F, which is findability, can be achieved if you provide metadata to enhance the discoverability of your data, regardless of what kind of data it is. If you provide persistent identifier to your data, you are essentially addressing the F component of FAIR. If you clarify in concrete terms who should have access to your data and how that access will be provided, you are covering the A aspect of the FAIR principles. The use of common standards and open data file formats essentially help in making your data interoperable. Again, regardless of whatever kind of data it is, it should be research data. Reusability, on the other hand, can be achieved if you provide good documentation and also outline the terms of the use of the data in clear terms. So within this kind of spectrum, I will be talking about how these things can be achieved when it comes to research software. So to start with, yeah, this essential translation of fair or transformation of fair data principles to software domain was actually done by the FAIR for RS in the FAIR for research software framework. So where they explain how F, A, I, and R are translated into the software domain. So F essentially means that your software and its associated meta is available, so that software is findable. Accessibility is when your software and its metadata is retrievable via standardized protocol. I'll explain a bit later how it is done. Software is interoperable Software interoperates with other software. So software, standalone software is important, but sometimes it needs to generate output or it needs to communicate with other software. If it's actually implemented or software is developed that way, essentially, I component of the FAIR principle is being met. Now, software is both usable and reusable. It's important here. Normally, we talk about reusability when this R is talked about, but in software, it's very, very important that it's usable and reusable. So I'll explain what actually the difference in my coming slides. So let's dig a bit deeper and see what exactly yeah, F, A, I, and R are when it comes to software. So F component actually is, as I said, linked with the definition of or documentation of the metadata and the persistent identifier. So how exactly that can be achieved? So when a software needs to be published or shared, software as a whole can have a persistent identifier. It can also have persistent identifier uh, for different versions of the software used at a different point of time during research work. Or importantly, if only certain components of a software actually needs to be shared, then those components actually can have their own identifiers. Now, what happens is quite often researchers use these standard URL from GitLab or GitHub and put them in their paper without, well, those URLs are not considered persistent identifier. Just imagine it's a kind of HTTP URL of GitLab or GitHub. At some point of time, if they change their name or the URL is changed, essentially these published outputs, the papers, for instance, have broken link. So it should definitely be a persistent identifier, like we promote among researchers to use persistent identifier for your other kind of research outputs, where software should also use persistent identifier. But how it can be done or how it can be achieved? GitLab, GitHub, these software management tools, they don't provide persistent identifier. And so that means you need to share your code via a trusted repository. Zenodo, for instance, has this built-in functionality where you can automatically put or bring in or fetch a very specific version of your code into Zenodo, get a DUI and put it in your paper. Code published that way is more persistent than published in a standard GitLab or GitHub way. And it's also important to publish your code or with a specific version. Now, quite often researchers publish their code via GitLab, but then they start modifying that code, which essentially change the nature of the shared code. It is not exactly the one that was used to publish results in the already published paper. So it's very, very important that a particular version is frozen in time and shared with a standard trusted repository, Zenodo, for instance. These repositories also allow to document metadata, like for any kind of data. It also allows to document software metadata as well. What it can include is like the standard description or title of the software, also some keywords or some dependencies of a particular software shared in a trusted repository. So if a code is actually shared via a trusted repository, in nutshell, essentially it covers the whole F component of the FAIR principle. So that's very handy and useful that you don't have to take care of all the sub matters in this component. So as I said, Zenodo has a very good integration with GitHub. It harvests and fetches a specific version. You get a UI and it makes your code citable. So then what is accessibility? Now, as I said earlier, that accessibility deals with how and who can have access. So who can access? means whether it's publicly available or restricted to a particular group of people, which may require authorization to get access, or if it's public available, anybody can actually have access. How it's available? It should actually be available via a standard protocol. We all know that most of the resources actually are available nowadays on web, which uses make use of the standard protocols like HTTP or HTTPS. So essentially, again, if you put your code in a repository and it's available via web, this component actually is also is covered. An important actually aspect I want to share here is that sometimes researchers are reluctant to share their code for some reason. That's fine. But what they can do is that they can still document metadata as I discussed in the F component. So what it will do is like the source code will be discoverable. Your tool will be discoverable, but access will only be provided when users can make a request to you. So that's why, I mean, here it's important to really think about who and how the access will be granted to the code. So bare minimum document metadata in a trusted repository so that it's discoverable. Interoperability, is another important component for any kind of data. In other kind of data, it may have different meaning, but in software, it essentially means that this particular software that you want to share should be able to communicate or interchange information with other systems or tools, for instance. And how you do it, there are different ways to do it. In its very simplest form, interoperability in software can be achieved by using standard output file formats. So if a researcher actually has implemented a pipeline that generates data in a very specific file format that no other tool knows in the world, then yeah, you are not making your tool interoperable. So on the other hand, if software actually writes outputs in a standard output file formats or open file formats like maybe CSV, for instance, or text file format, then yeah, other tools might actually read the output in an easy way. There are few sophisticated ways of achieving interoperability. Is one of them actually is application programming interface, APIs, known otherwise. Um, yeah, depending upon the skill of the researcher or people who are involved in that, APIs can be a bit complicated or more technical stuff. But essentially what it does is it exposes access to the internals of your code by providing some nodes which other parties or other tools actually can implement on their part to interact with the code. So that's also an important way of doing that. In its simplest form, as I said, software if is outputting in a standard file format, that should be enough. So reusability. Yeah, as I said earlier, that it's reusability, but here in this context, it's also important that it should be usable. Now, if a code is fair, well, it's findable, it's accessible, it might be interoperable. So if somebody has downloaded it, but it's not working, if it's an executable software, nobody can actually execute it. Yeah, it's unusable or unuseful, I must say. So it's very, very important that software, when it's being developed, uh, should this important aspect should be kept in mind that it should work and it should do its job, of course. Reusability also can have different actually aspect in this particular context. One is that it should be modifiable. So if I want to build a shared software there, which I have downloaded recently, I should be able to extend the functionality if needed or if license permits. And that's not an easy thing to do. Where is it actually handled? It's handled during the design decisions. So while researchers are developing software or designing the software, I must say, this importance should be taken into account by designing um, different components of software such a way that other people can understand them, reuse them, and build upon them if needed. Uh, yeah, one of the most important aspect for any kind of data, especially for research software, is have a clear license and appropriate license. Clear license means that it should really clearly define the terms of the use. Sometimes researchers, well, most of us actually don't have expertise in choosing the right license and let alone understanding what exactly those terms and conditions are, because those are the legal terms and conditions. But yeah, it's very, very important that before data is shared or software is shared, that terms are understood clearly, and those terms can have a kind of conflict with the purpose of sharing. If the purpose of sharing is that this code actually should be reused and should be able for other people to modify this, and the license says otherwise, then it's a complicated situation. So it's very, very important that appropriate license is used. I will uh, yeah talk about that later as well.
Yeah.
Reusability or usability is also linked with good documentation. A software that's downloadable but says nothing about how to use it, how to build upon it, can be a kind of complex thing to use. You might have to spend a lot of time yourself to really understand it. So think from the user's point of view, what kind of documentation is needed. I'll briefly talk about how and what kind of documentation can be provided for a software. For usability, it's also important that software meets the community standards. So different communities in the research communities may have their own specific way of documenting software, for instance, and it's good that those standards are met. Now, as you might have guessed, that fair or fairness is not a kind of binary thing that either it's available or it's not available. Uh, it can have different levels of fairness. So either, I mean, if you have provided really or covered all aspects of the fairness that I just described, then you are really a very well motivated person, and your software is really, really fair, has highest degree of fairness. On the other hand, if no someone is sharing code and did nothing, just put it on GitLab publicly available, put the URL in the paper, that's unfair in my opinion. But there are a lot of in between as well. So it could be depending upon the needs, goals, and the circumstances, that your code has a persistent identifier shared via Zenodo, for instance, and your paper has a URL, but code is unusable. I mean, it's not possible to understand the code and let alone use it. So that means you are not covering that part of the fairness. And it could be that you have documented the metadata in a repository, but yeah, there is no clear license. It's discoverable, but the license is not clear. Then yeah, it may have some sort of fairness, but not really a good fair. Likewise, dependencies are very, very important in software. Quite often researchers use third-party libraries without knowing that it might have conflict with their own license that they want to use. And providing no information about the license or dependencies might affect the fairness as well. So the goal should be to have maximum fairness in the published software, but anything in between should be enough as well. Yeah, I would like to talk about software management. So when we talk about software code, the management of the code is very, very important, but I would like to discuss that from the point of view that it can enhance the fairness in software. It's very, very good to really have good management, but how it impacts the fairness, the topic of today's webinar, is also very important. We have various tools. Yeah, some of them all of you, I'm quite sure you know, GitLab, GitHub, Bitbucket. They're all tools. What they do is they let developer of those research software keep track of the changes. What does that mean? That who made those changes, what that change actually is, when that was made, why that was made. And it allows you to move from the standard practice that we all often make, software version 1, put it on our hard drive in another folder, software version 2, software version 3, and then when we need a particular software, we go back, explore or navigate those directory structure and find the suitable one. But if that code is put here, regardless of the magnitude, how small it is or how big it is, using these tools can be very handy. How it can be handy is like if you want to really go back in time and find a kind of that specific version that you use to publish a particular output in your paper, simply search for a particular tag, or yeah, there are different ways to do that. Find a particular version and use that. And it's, as I said earlier, it's also possible to publish a particular version, and that's a very good practice. So a particular version that was used to generate some results which have been reported in a scientific publication should actually have a DUI of that particular version, and that is possible with these kind of tools. And then again, there could be another aspect, how to manage this code on GitLab. So one of the standard RDM practice actually is, if this code is being developed in a research group, it's always good that you have a group space in these tools where you have a subspace for your own projects or your own research, so that when actually yeah, a particular person leaves that organization, the code is actually available still within the group. Another important aspect, especially linked with the reusability and usability of the code, is good documentation. Now, we all know that good documentation is important for any kind of data. It is super, super important for software when it needs to be reused. There are different levels of documentation. If time permits, I'll go through that later, but there can be at least two levels where documentation can be created and provided along with tool software. One is at the top level. It can be called a project or tool level, where essentially you are providing information about the use of the tool, describing what this tool is, and maybe some information about the design of the tool, especially the dependencies. Another level is the item level, where researchers should document or provide some information within the code files themselves. Essentially, that means that next to the functions or the codes that are being developed, write some sort of description so that if somebody wants to build upon that, it's easy to understandable. There are certain tools or standard practices that are available. Some of them actually I have listed here. So documentation is really, really important.
Naeem, I'm giving you a 5-minute warning.
Yeah, thank
Yeah.
you. So yeah, I'll speed up. Software quality checklist. Yeah, before any kind of data goes, especially software, it's very, very important that quality checklists are used to assess the quality. In this particular case, I listed some of the aspects, which is like the general quality, documentation aspect of the software, interoperability, administration. More information can be found on the link. But I would like to, mention this particular component of the software, which is choosing a software license. As I said earlier, it's important, but on the other hand, researchers whose core job actually is to do science might not have the necessary skill to identify which license they need. There are different kinds of license from the public domain, where everything is available to do whatever users want, to the other side of the spectrum, where uh, uh, it's a kind of proprietary code or software. It's most restrictive, no modifications or no actually redistribution is possible. But to assist people who do not have the necessary knowledge about that, there are certain tools available. I have listed two of them here. It's important that actually choose a license, and if you don't have the necessary knowledge, one of these tools can be used. Now, one important aspect while choosing a license I would like to highlight is, which sometimes researchers ignore, is if you are using third-party libraries, it can be a Python library or some other packages, they have their own license. They have their own restriction on the sharing. So it's very, very important that uh, look into the terms and conditions of those library or packages, because you can't choose any license if there is a kind of conflict. The Netherlands eScience Center and DANS put forward 5 recommendations, which I thought really are very important. And what they are in line with what I just said. Use a version control repository. Register your code in a community registry. It could be a kind of trusted repository, for instance. Enable software citation by using persistent identifier. Use a software quality checklist to make sure that software is good to be used. And importantly, add a license. Now, I wanted to use this checklist, but I think given the time restriction now, there are certain checklists. One of them I have listed here, where you can actually assess the fairness of the research software that you plan to publish, or you want to assist somebody else to publish, to see how much fair that piece of code actually is. So the take-home message from this talk is that for sure, script, tool, or source code is a research data. Don't ignore it. Apply FAIR principles on them. Use a version control tool repository because it covers a lot of actually aspects, especially the quality related part, which is related to the reusability component. Make your software citable by using persistent identifier. Provide good documentation to use or make your code better extendable. Use a quality checklist to assess the quality of the software. And very, very important, again, I will emphasize, use a suitable license. I have put forward some of the useful links here, resources. We will share these slides later. So please, go ahead with them. That's it. I'm on time, Eliza.
You are definitely on time. Thank you, Naeem. And I see that there's been a lovely conversation in the chat. And I think that we will come back to that in the general Q&A. Thank you so much. I think this sets us up really well for the second presentation of today. And that is a presentation by Teresa Gomez-Diaz. And Teresa is the Centre National de Recherche Scientifique Research Engineer at the Gaspard-Monge Computer Science Laboratory at the Université Gustave Eiffel in France. And basically, Teresa's mission is to render research software and research data production visible and accessible, and she is a long-time open science advocate in France. In this talk, Teresa will present partially some of her work on research software that will set the context of the second part, which is dedicated to the research software management plan, PRESOFT. And that's apparently short for the preservation of for research software software management template. The talk will end with a little resume of other works on software management plans. And I will immediately stop sharing my screen and give the floor to Teresa.
Thank you. Thank you, Lisa and Hannah, to invite me to do this presentation. Thank you to Naeem for the very interesting presentation as well. Do you hear me correctly?
Yes, and we see your screen as well.
Perfect. So you have all the introduction already. So my talk has two parts. The first one will be dedicated to research software. You will see how this work complements everything that Naeem has told you. And the second one will be for the research software management plan pre-soft. So I am very lucky to work with Professor Thomas Recio since a few years. And we have done several papers. The first one was this one on research software. And we have done later other papers on open science and research software and research data. And Thomas is a person with a long experience in computer science, in computer algebra, in many areas in mathematics and computing. So in this paper, we have proposed this definition that is a bit different of what Naeem has presented you. So for us, research software is a well-identified set of code that has been written by a well-identified research team. It is software that has been built and used to produce a research result that is published or disseminated in some scientific contribution. We are in a digital world, so its research software is in fact a set of files that contains the source code, maybe the compiled code. If you have no scripts, there are more complicated software. And there can be other elements like documentations, use case, examples of use, etc. There can be very simple or very complex objects here. In fact, my work started a long time ago in 2006 in my research laboratory, in a computer science laboratory. The direction asked me to have a look to the research software produced in the lab. And so I started to do publications, mainly in French, about the subjects. You will have the slides, so I am not going to enter into many details because I have too many things to say. So for us, one of the important things is to understand software as a legal object. I give you here the legal French context and the European context. Why is this? For example, when you compare software and data, the legal context might be very different. So this is what is important, is one of the reasons to take care about this question. And why it's important to understand the legal issues? Because it defines who is the author of a software. The person who writes the code is the author of this object. But we are also in a scientific world where there are many researchers that start projects with software development, but maybe they are not writing the code. So in the legal vision, there is one thing, and in the scientific vision, there is another thing, which is a bit different. And there are also maybe other contributions, writing documentation, do testing, maintenance, etc. So in this work, we have proposed 3 roles. We have selected 3 roles to be associated to this object. Who is the leader? Who is the leader of the project? Maybe with a very important scientific role. Who are the main contributors? There are maybe many who are writing the code, and maybe there are other kind of contributions. And the persons that do not write the code may have some kind of participation decided by the team. You know very well in the LIBER community that the importance of citing data. So for software is the same. It's important to cite the software. And as well in this work, we have proposed three different ways to provide citation forms of this object. The first one is, you know all about data papers. There is something called software papers, maybe with a software peer review procedure. Usually in the scientific teams, there has been a lot of software development, but what the people did and still do is to write a normal scientific article describing the software and the result. The result, yes, no. And then, for example, when you deposit your software in Zenodo, you can have this kind of reference with authors, title, etc. And you have here a lot of work that has been done about the citation of software. As I told you, I started to work in the subject of research software a long time ago, and at the time there were no the FIRE principles. So how to deal with the problems that I did see, I did view in my lab, and also I did work in a national project in France. So in my lab there were people doing things correctly, but many persons, they didn't like to take care about licensing, and so in 2010 I did a first publication in French. This is why the reference is not here. In order to say, before giving the software, you should choose a license. And before choose a license, you should take care about who are the persons that had contributed to the software. For example, the software management plans appear in this protocol for dissemination. And you may find here all the words, well, many of the words that Naeem has mentioned, the use of license, the use of standards, etc. Documentation as well. And in this work with Tomás Recio, we did propose an evaluation protocol. Why? Because you have seen in the chat as well, it's important to recognize this work, and it's not very well recognized. We are still evaluated regarding the publications we do, mainly. These are things that are changing a lot now, but it's still difficult to change things that have been working since long in some way. So we have proposed this protocol in 4 steps. The first one is related to the citation issues, dissemination issues, and then we like it to separate when you are evaluating software and when you are evaluating research. This is very important for us. And in this step, the use step, we have put the reproducibility, and in the research is the impact of research. And here is the connection with Naeem's talk, because we did this poster in 2023 in the Open Science Fair in Madrid. It's written for data, but it's the same for software, as you have seen. So this is another way to understand the FAIR principles. For example, you might find dissemination for us is important, the license, and you may find here the reusable, the license issue. So now I'm going to pass to section 2 about the press of work. So PRESOF is a very little project that was funded by a section of the CNRS, And the goal is to study the implementation of software management plan in research units to improve their sustainability. We were a very little team. I did work with the project 2 years. Then the project had another year, but I wasn't there. So my colleague Genevieve has retired, so this is why she's not here. And the main output of the project is this research software management plan template that I am going to present you now. It's available on Zenodo, it's available in the HAL French repository, and it's also available in this service in France. So, what is a management plan? It's a tool to improve software sustainability. It's a roadmap to manage the software life cycle. The plans should be adapted to the software and to the team. It's not the other way around. It's a tool for reflection, to plan, to ask questions. Maybe you have the answer, maybe no, or maybe you will decide that next year this question will be really important, or maybe not. It allows the team to identify the different stages, the main stakeholders, and the responsibilities. It's a tool to better manage and to centralize the information. And this is an important thing because sometimes the software may have 5 or 10 years of the development. And after 10 years, you have lost information or you don't know where is it. So it's important to sometimes to keep information in somewhere. And a development plan is not the same as a research software management plan. This is the vision we have. In research, sometimes there is a real project with a vision. You have a goal and you like in 1-2 years a software doing this and this and this. But this is not very useful, in fact. The usual thing is to start to write code somewhere and maybe you will forget it at all, or maybe it will become a more important project, and then you will ask for funding, and then you will get or not the funding, but you will continue the development. You use it for your research, and at some point, maybe you will decide to disseminate the software and to do publications about the software, or just disseminate the research results. This will maybe generate new collaborations, new ideas for research, and then you start again the development, the utilization, etc. Software life cycles is something that exists since long, and you have here an old reference and a new one, a real recent one. But there is always this idea of a spiral that the development goes on and gets more and more important. This is the sections. I will know. These are the sections of the Presoft template. As you can see here, this is the plan, the index of this model. Sorry. You see it's a French-English document, bilingual document. The first part is the title of the plan. I will show you later if we are not late, I will show you the plan, the model. The first thing is the title of the document is a plan of your software, and there will be dates, authors, and affiliations. The first part will be to have a good description, metadata description of the software. Then we have a section to look to the history, to the projects which are related to the software. Maybe you have a European funding or a French funding, and obviously very important, the legal issues. Then you you will take care about the software issues, the scientific goals, so not just software, but also research, which are your goals around the distribution and the dissemination, and the technical things is software for Windows, for Unix, or has been developed with C++ or with other things. Then we take care about the team organization. It's very usual that there is only one person in the team who have every role and does everything. But you have a team with more persons. It's maybe important to say this person will do this and this person will do other things. So the team organization, the development organization, the dissemination organization, and who takes care of the document, who is the responsible of this document. So as I told you, this model is available in a way where you can modify it, or is available in this service. So here you have a lot of manual management of the document. You have the French and the English version in the same document. And you can maybe share parts or no with the software or no. It's the team decision. And you have, you use this service in France, the questionnaire is online. You have only one French version or only English version. You can export different parts of the document. There are several roles, etc. When I was working for the PRESOT project, in fact, I took the time to work with people in my lab and to sit down with the researchers. So I was the person writing the plan, the PRESOT model. And so because I didn't like to take the time of research, so I went to see some people that I knew well. And so they were sitting around me, behind me. And so I asked the questions, and I did during half an hour. It's not very long. And this is the way we were very sure that the PRESOT model adapts to the real thing, to the real people doing software in a computer science lab. I have done some more work in 2024, last year. So which are the benefits? It's important to get a general overview of the object. It's important to better organize the work, the monitoring of the work, to improve the management methods, to save time. It helps to identify what works well, the needs, the risks, to avoid bad surprises as far as we can. To implement a strategy is a document to think about what you like to do, to improve the quality of the software, and then the team research quality, the quality of the research done by the team. It facilitates the reuse and foster new collaborations, and is a tool to increase integrity, transparency, visibility, and impact. For a lab, this kind of documents can be interesting, for example, to improve knowledge about the production of the lab or the institution. It may help to decide which are the important productions, which are the ones that needs more funding or persons. Is a tool to increase, again, as I said here, is a tool to integrate integrity, transparency, visibility, and impact of research, of the team and of the institution as well. It can be a tool to facilitate policy implementation. regarding the software and the research in general. In 2024, we have seen new recommendations that didn't exist before. For example, this one in Science Europe, this one in a UNESCO document that deals with a scientific matter, open hydrology. But this document is very interesting. It speaks a lot about software and about data. And this year, we have seen a NASA document that also speaks about software management plans. In this slide, I like to give a vision about the existing work. Sorry. You should know that software management is something that exists since a long time. But in the context we are working now, the first work comes from the Software Sustainability Institute that published a checklist in 2016. This work has been revisited in 2018. And here you have a link to a workshop. There is also the Elixir work. Elixir is a project or some kind of organization for life science, and you have the references here. The Netherlands is doing a lot of work around software management plans, so they have a template and a document to explain the work. And more recently, there is a lot of work in Germany, for example, in Berlin, in the Max Planck Digital Library. And still more recent is this work from Canada. I didn't know it. I just found it this month. I work in Canada, very recent as well, and a new plan in France. This plan, in fact, has a very, this work in general is a bit different of the vision we have done. I would like to mention this work from Yves and Giacomo and other persons in Germany. They have done a very interesting work comparing 5 existing works. In fact, these two they were not existing, so they couldn't work on this. And in fact, you see here, all the data is public, so you can check. The document is very interesting. All the data here, the comparisons, etc. You may find that our piece of work is a bit complex. There are several reasons for this. As I told you, a software management plan is not the same as a research software management plan. So we talk a lot about research. For example, here there is a more simple document to deal with, but there are things which are, in our view, a bit missing. Last year, I organized a workshop in Paris, and there will be maybe a new version of this workshop next year. After this work, in this workshop, there were a lot of questions, so I did a little document to explain the questions and the answers. And there is also a very interesting podcast done by Peter Smith of Code for Thought. And in fact, in this podcast is very interesting discussions. And one of the main messages is the questions that matter. Maybe one of the important things is that the Presot model, this is one of the reasons why it's a bit more complex. The Presot model is conceived in a way you can start it at any time. Maybe the software don't exist, then you take the document and you will have answers for some questions, or maybe not. Or maybe your software have 1 year, 2 years, 10 years. So the questions are important, and maybe you have answer, maybe no. But you should take care about the questions. So then we have a lot of references, and if you don't mind, I will open the model. I have time. Everything's fine from the time.
Yes, you have a few minutes. Please show us. Yes.
Okay, so I opened the other document, this one. So the document has a long introduction to explain a lot of things, but the important thing is this page. I don't know the number of the page. This is the plan for, the research software management plan for your software with versions, because it's a document that should be revisited regularly. And the version, the date, and who are the persons who write the software. As I told you, the first section is metadata. So it's French and English at the same time. And you have the first section to identify the important data about the research software. Here I gave you links to find the keywords to put the software you are doing in a scientific context. The links are not working anymore, but for example, for the ERC, there are new documents. You will find it easily. And there are also now more, there is also there is some American society, mathematical society that has a lot of scientific classifications. You may find a lot of places where you can take the words to classify your scientific work. And there are other keywords for the software. So the second, as I told you, is the history. Maybe there is some preparatory material, maybe not. Are a lot of versions. Maybe you are in the first one or in the 10th one. There has been publications. Maybe they have been done, or maybe you will do for next year a publication. Are the data, research data associated to the software? I like it to tell you about this section. For us, it's very important. When I did the software management plan of one of the softwares in my lab, I was with a researcher, and so he did have a very important funding from a European project, I think. So, but the information was nowhere. He didn't remember how much money did he had from the project. And then it was the time where we went to check if his software was listed in the web page of the project, and it was missing. So these are important things that the researchers, they do have a lot of work, and they have many things in the head. They were important things that we corrected when we were looking at this section. And maybe you will have one European funding 1 year, and then next year another funding coming from the national project, etc. So you can take this section and reproduce it as many funding you have. The legal issues, the intellectual property, maybe the project is putting you some conditions about the dissemination of the software, or maybe not. And then the software issues, the organization of the team, etc. So it may, and last one is who manage the plan. So this is what I like it to show you. The document may seem complex, but please, if you have a look to this document, don't care about the questions you don't have an answer. Maybe you will have the answer next year. Many thanks for your attention.
Thank you, Teresa. That was very, very interesting.
Thank you.
Well done, both of you. I think it's now time to open the floor for questions. It might be nice if you want to ask the question that you unmute yourself, and also please raise your hand if you want to ask a question. In the meantime, I have a question for both of you. Or actually, I have questions for both of you. And first of all, maybe Naeem, do researchers at KU Leuven already write software management plans? And if yes, how? And are they supported by anybody? Do you have? Oh, you are muted. Sorry.
Yeah, sorry, I was muted. Well, yeah, SMPs really are very important artifact, especially when it comes to have a kind of good quality research software and increase the reusability. We are not that far as such. The emphasis among researchers at KU and on research software is primarily addressed within the data management plans. So it's primarily linked with actually the DMP requirements from different funders. But I do see is really an important artifact, and we probably should start using them.
Yeah.
May I ask a question?
Sure, go for it.
My question is, it goes here basically about software which is developed by research group, or you can also spread it on software which you use from some certain companies which have for the same process, they have different generation of devices and different generations of software. Is it also covered by this presentations today, or it is only from personal software developed by groups?
You mean the software management plan template?
Yeah, exactly.
Yeah.
Exactly. Why I ask, I can shortly tell, because I was working with software for ultrasound investigations, and there were several generations of devices. Software also was so to tell in several generations. I thought always that we need data management software management plan, but this is what we heard today is idea of data management plan. Is it spread also on software of companies? This is the question.
I can try to answer. Thank you for your question. In fact, the Presolve model has been done in a research lab to answer to the questions that I have seen in my colleagues in the lab. You could try to check this document and see if it's useful for you. I have no idea. You should know that software management plan is an old issue. There is work, and I didn't have the references in the presentation, but I could, if you contact me by mail, I could try to find you some references about software management. For me, in my view, the software we do in the scientific world is a bit different. The teams doesn't work the same as in a company. The goals are not the same. The way to disseminate things are not the same. So I really don't know if my document could be useful for you. You could try, but it's not the context. The context is really a research lab.
Thank you so much. Yeah, I understood, but I will try to maybe contact you, maybe formulate my question more. So.
Yes, please.
Thank you so much. Thank you.
If I may add the other perspective, let's say how far you can go in terms of like using FAIR principle in a non-academic setting. So yeah, there are still quite some possibilities. For instance, you within that the development environment of the software development environment, you can use persistent identifiers for different components or versions of the software, and also document metadata within your organization to increase the findability. You can, of course, provide good documentation so that new people or new users are able to understand, or reuse the code well. Yeah.
Thank you. Thank you.
Are there other questions that you would like to ask? if you are still mulling the question that you would like to ask, I have another question for Teresa. So you mentioned that this pre-soft model came about a little bit by the conversations that you had in your lab and the problems that you experienced, but it's now that it's also available on Opidor and as a national French project. Do you have any idea who else is using the template? And also, could the template potentially be used by someone who is not in France but who wants to write a software management plan?
I will try to share the document again.
Yeah.
So in here, I gave you the downloads. So this is the number of downloads as yesterday. This is the stats of yesterday. This is the number of persons that have taken the document in France.
Yeah.
The French repository is open to everyone, not just for France. And this is the downloads in Zenodo. So I think that around all these persons, someone is using it.
Yeah.
And as far as I understand, no one has come to me. I stop sharing. No one has come to me to say this is not working or I don't understand anything. So I don't know. I don't know around all these persons how many are using it. But it was a way from the German team when they were working on the publication. They did contact me, so I started to work a bit with the German team. But they are people providing the service, no researchers using the document.
Yeah.
So I don't know.
Yeah. If please raise your hand if you have a question, but I will continue asking.
Otherwise, maybe an interesting question that we often get actually is about how much effort actually one needs to put around making data fair, software fair, and doing the actual science work. So usually we advise researchers, especially researchers who are really involved in software development, to see what the goals are. I mean, if the goal actually is to just build something quickly and the emphasis is on producing the results, then it might be important to consider only the critical components of the fair. But if the research processes are really based on or very intensively depending upon the research software, then a lot of effort should be put, especially the use of these SMPs is very, very important in that context to make sure that the quality of the software is high and also the fairness.
Yeah. Actually, I think that's also part of the Dutch software management template that was created by the Netherlands eScience Center, which is kind of scalable. You can skip sections if they are not applicable to the software that you're writing. I also have a question for both of you, and I wonder if you have different perspectives on this. So how could the writing of a software management plan be supported? And is the supporter required to have specific roles or skills? What are your ideas about that?
Naeem?
Yeah, well, it's a tough question. I find myself in a difficult position because of my background is software engineering. So for me, it could be a kind of it's easy to understand the complexity required around advising those people who are developing software, that I have the necessary skill to large extent. But from those people who do not have the necessary skill, this sport can be a bit complicated, and it can be left largely up to researchers to really think about that. You can create these kind of artifacts with some examples and give some trainings around that with from skilled people. But yeah, I think you really need domain specific knowledge to advise involved people.
In my context is one of the important things were the legal issues. It took me a long time to understand, because I have a scientific background. I didn't understand anything about legal issues. And when, as everybody start to receive questions, what is the license I should use? And I say, well, maybe. And then who are the authors of the software? I don't remember. There was a student that left the lab 5 years ago. So the legal issues are complicated. And I have references with training support that explains these questions. Which is not regarding legal issues, is not very different of research and software. The questions are related to software dissemination issues, and then you touch license and legal issues. The research, they know very well about the research, dissemination, etc. So sometimes, yes, you need a bit of background to accompany the dissemination. In my life, the question is that there is no policy. When I offer the service, the researchers are very happy because I write the document and then I give it to them. But there is no policy. Now, as I told you, we start to see recommendations from very important institutions that speaks about software management plans. But this is still not in the same level as data management plans.
Yeah.
So we will see. It will come. We will see.
Yeah. And someone in the chat suggests that these questions could also be discussed with the legal advisor for the university or the administrative.
I would like you to listen to the podcast. In fact, one of the things I understood is that the legal issues related to software development is very specific. Is not very difficult to understand, but it's very specific. And there are no, even in the legal world, there are not many persons who understand all this very well. So please listen the podcast. It's very interesting.
Yeah. All right. Thank you both very much, and thank everyone for attending. This was a webinar organized by the LIBER office in collaboration with the Research Data Management Working Group. I just wanted to show you where you can find more information about our working group and potentially join the working group if you are interested. In any case, thank you so much for being here, for being so active, and especially in the chat as well. And thank you, Naeem and Teresa, for speaking and showing us such different perspectives also on research software management. And I wish you all a lovely afternoon.
Many thanks to you.
Thank you very much, everybody.